I wanted to go over a couple of the applications that we sped through in class. This application exercise 2.7 was the second of the tax exercises, and it starts with the $3.50 tax on each sack of potatoes. And it really, the analysis is the same whether we collect that tax from the buyers or the sellers of the potatoes. Anyway, what we're asked to do is to use a colored pen to analyze the tax on the supply-demand graph. I've got that in the next page. And then I want to label the new price paid by buyers, new price received by sellers, and the new quantity of potatoes exchanged in the market. And then I want to add the appropriate welfare analysis to the graph. So let's get started. Let's pick green to analyze the tax. Actually, I'll start with a pointer. Remember that what we're doing when we analyze a tax, we're analyzing a tax at $3.50. So here you can see, and I've got the grid line, so we know each of these rectangles is 50 million sacks of potatoes wide and $1 high. So we're looking for the quantity such that the vertical distance between the price the buyers pay and the price that sellers receive is exactly equal to $3.50. So notice that a quantity like $380 million, the price paid by buyers is $8. The price received by sellers is $5.75-ish, something like that. That's too high of a quantity. That vertical distance is smaller than $3.50. Likewise, if we looked at a possible quantity like 300 million sacks, notice that buyers are paying $13 per sack, sellers are receiving $5 per sack. That's an $8 tax, and that's way bigger than what we have here. It turns out that approximately this quantity of 350, notice the buyers would be paying $9 per sack, sellers would be receiving $5.50. 9 minus 550, that's our 350 tax. There's only one quantity where that vertical distance is exactly equal to the size of the tax. In this case, the tax is 350. There's our analysis. Let's draw that in. Okay. I don't have a ruler, but I can be pretty precise here. No sooner do I say that than I get a little bit wrong. Pardon my less than perfect drawings. But anyway, so the new price paid by buyers is 9. The new price received by sellers is $5.50. So a couple things to notice. The price buyers pay goes up but not by the full amount of the tax. The price received by sellers goes down but not by the full amount of the tax. In this case, buyers pay $3 of the $3.50 tax. Sellers receive just $50. And that incidence of the tax, it results because the demand curve is much steeper than the supply curve. That is to say, the demand curve is much more price inelastic than is the supply curve. All right, now we're asked to add the welfare analysis. Let's go ahead and do that. We'll choose a different color. Let's choose blue. I'll use two different colors. I'll use one for the no tax and one for the tax. The first thing you do is to glance and see, do I need any more lines? No, I think I've got everything. I've got the price without the tax. I've got the price with the tax. I've got the quantity sold with the tax. I've got the quantity sold without the tax. So I think I have everything. So now it's just a matter of labeling areas. A, B, this little skinny rectangle will be C, D, E, and F. Just the way I labeled them in class, I think. All right, without the tax, notice that the price, the value to consumers of each successive sack of potatoes is given by the demand curve. Without the tax, price is 6. The dot is not going where the end of my stylus is. Strange. Anyway, the price is 6. The quantity demanded is 400 million. So we notice that the area under the demand curve and above the price paid by buyers, areas A, B, and E give us that. Let's hopefully when I write, my pen will work. A, B, E. Producer surplus, same logic, only now producers, the benefit is the price received, the cost is given by the supply curve. Notice the excess of benefit over cost. If we add it up over all the potatoes sold and the market outcome, we're left with areas C, D, and F. There's no government revenue, there's no tax. A, B, C, D, E, F. All right, now along comes this tax. Under the tax, the price buyers pay goes up to 9. The price sellers receive goes down to 550. The quantity sold shrinks to just 350 million sacks of potatoes per year. Notice that consumer surplus, area under the demand curve, above the price paid by sellers, we're down to just area A. Producer surplus, down to just area D. Government's collecting 350 per sack, selling 300. There's 350 million sacks sold. The total government revenue is the area of this rectangle, the amount of tax per unit, the number of units sold. We get areas B and C. Remember this little skinny area was area C. All right, and we total them up, A, B, C, D. Notice that buyers of potatoes lose. They lose areas B, E. Sellers of potatoes lose. They lose areas C, F. Government revenue, citizens, the government now has money to pay for goods and services supplied to people elsewhere in the economy. So that's not surplus wasted, it's just transferred from people buying and selling potatoes to people elsewhere. Of course, many citizens actually participate in the potato market in addition to receiving, being able to go over government-funded bridges, etc. And then finally, the change in the total. We used to have A, B, C, D, E, F. We now only have A, B, C, D. We've lost area E, F. And as we know, this bottom right square indicates the deadweight loss, which is the difference between total surplus, total well-being, according to this measure, under the tax compared to under the most efficient case, which under the assumptions in play here is in the no tax case. All right, there we have it. It's a lot to learn, practice. You can give yourself different markets and practice analyzing taxes, and I would recommend doing that.